Here is a summary of what we did in class on Tuesday, October 4th. First, in groups, we worked on a conjecture together, after which we practiced a geometric proof of our conjecture. Then we talked about this big idea, which is actually in section 3.1 and 3.2, of when two lines are crossed by a transversal. I'm going to quickly review these things from class on Tuesday, and then we're going to take a look at a few examples here on this short video. For our group conjectures, we started with this picture, and groups practiced identifying all the linear pairs in this picture and all the pairs of vertical angles. Each of these pairs are the linear pairs, and you should stop the video and think about 1 and 2 and why they're a linear pair, and etc. And each of these pairs are vertical angle pairs. And you should look at the video at these two green angles, 1 and 3, and recall why they are vertical angles. And the same for 2 and 4. Next, we considered the case when there were two lines that were crossed by a third line, and we called this third line a transversal. So again, when two lines are crossed by a third line, then we have 8 angles that are formed, and within this set of 8 angles, we have some new types of angle pairs to identify. What we learned in class is that there are corresponding angles. For example, 2 and 6 are corresponding. There are alternate interior angles, for example, 4 and 5, alternate exterior angles like 1 and 8, and consecutive interior angles like 3 and 5. In these pictures, the blue lines are the transversals. In between the two lines, not the transversal, is the interior, and that's why 4 and 5 are interior angles, and they alternate on either side of the transversal. If the angles like 1 and 8 are not in the interior, then they are in the exterior, and if they are on alternate sides of the transversal, they are alternate exterior angles. When you're on the inside and you're not alternating over the transversal, then you are consecutive interior angles, otherwise known as same side interior angles. Alternate interior angles. Angle 1 and 7 are alternate exterior angles. Angles 4 and 5 are consecutive interior angles, or same side interior, as are angles 3 and 6 together. They're a pair of consecutive interior angles, or same side interiors. Angles 1 and 5 are corresponding angles. They're in the same corresponding position relative to where the transversal crosses the line. Left and up, left and up. Similarly, angle 2 and 6 are corresponding angles. Angles 3 and 7 are corresponding angles. Angles 4 and 8 are corresponding angles, and we've already established that angles 1 and angles 5 are corresponding angles. Next, we explored what's true about all these new angle pairs if the lines that are crossed by the transversal were parallel. When lines are parallel, they will never touch each other. They maintain the same constant distance away from each other at all times, and we indicate with this notation. 2 parallel vertical bars means that line H is parallel to line G. And in the picture, we put arrows on the lines, and if there are arrows on the lines, that means automatically that those lines are parallel. So what happens to be true about same side interior, those consecutive interior angles like 4 and 5? Or what about corresponding angles like 1 and 5 when these lines are parallel? When the green lines are parallel, we have a lot of relationships about these angle pairs, and here we summarize them in class. When the two lines that are crossed by a transversal happen to be parallel, then the corresponding angles will always be congruent. The alternate interior angles pairs will always be congruent. Each pair of alternate exterior angles will be congruent. And each pair of consecutive interior angles, or same side interior angles, they will be supplementary. And so we introduced ourselves to 4 new theorems: the corresponding angle theorem, alternate interior angle theorem, alternate exterior angle theorem, and the consecutive interior angles theorem. We can abbreviate these as the corresponding angles theorem being CA theorem, the alternate interior angle theorem, the AEA theorem, alternate exterior angles theorem, and the consecutive interior angles theorem, the CIA theorem, or same side interior angles theorem, SSIA. All right, so it's time to look at some examples of this, after which, when you do the cloud assignment, things should be pretty clear, and it should help you to develop your current level of understanding of these new ideas. All right, let's see if we can find X in this picture. Some observations to make are the green arrows tell us that the black lines are parallel. So if the black lines are parallel, remember, we should be thinking about corresponding angle pairs, alternate exterior angle pairs, alternate interior angle pairs, and consecutive interior angles. So what we might notice in this picture is that angle 1 and the angle whose measure is 9x plus 4 are alternate exterior angles. And we know that alternate exterior angles have to be congruent if those lines were parallel. So we know that the measure of angle 1 is equal to 9x plus 4. Well, the measure of angle 1 itself forms a linear pair with this 130 degree angle. And so if angle 1's measure plus 130 degrees is 180, we know that angle 1's measure is 180 minus 130. And that's equal to 50 degrees. So if the measure of angle 1 is 50 degrees, then we know that this also has to be 50 degrees because they are alternate exterior angles. So by the alternate exterior angle theorem, 9x plus 4 has to be the same as 50. Then we can do the algebra and do the subtraction property of equality, subtracting 4 from the left and from the right. Then we can do the division property of equality, dividing the left side by 9 and dividing the right side by 9. And we have it. X is 46/9, which is 5 1/9, or 5.1 repeating, and any of these answers are great. We have found X. All right, let's just take a look at one more example here. All right, in this problem, we like to find the measure of angle 1, 2, and 3 when we are given that this angle is 40 degrees and these two lines are parallel. Well, there's a lot of ways we can approach this. So since everybody's mind works a little differently, let's actually approach it maybe 3 different ways. So we might start by recognizing that these angles are vertical angles. And so the measure of angle 3 would have to be 40 degrees. And that's the vertical angles congruence idea. We proved that all vertical angles will always be congruent. So we can just say vertical angles are congruent. What next? Next, we might look at angle 2 and the 40 degree angle and recognize that they are corresponding angles. And we could say we know that angle 2 is 40 degrees because these two angles are corresponding angles. And if the lines were parallel, then the corresponding angles are congruent. Corresponding angles are congruent. It's the corresponding angles congruence theorem. This is good enough. What about angle 1? How can we find the measure of angle 1 in this case? Well, we could use the fact that angle 1 and angle 2 form a linear pair. Or we could use the fact that angle 1 and angle 3 are consecutive interior angles. If the blue lines are parallel, then consecutive interior angles like 1 and 3 must be supplementary. If two angles form a linear pair, like 1 and 2, then they're supplementary. Either way, we know that angle 3's measure is 40 degrees. Therefore, angle 1 must be 140 degrees. So if we use the relationship between angle 1 and angle 3, then we know that the measure of angle 1 is 140 degrees. Because angle 3's measure is 40 degrees, and these two angles have to be supplementary by the consecutive interior angles theorem. So 40 plus what number gives you 180? 140. So somebody else might have looked at this problem and said, I'm going to go straight to angle 2 instead of angle 3. So this angle that's 40 degrees and angle 2, they happen to be corresponding angles. So they could have said that angle 2's measure is also 40 degrees because of the corresponding angles congruence theorem. And then they might have gone to angle 3 after that. And they might have said angle 2 and angle 3 are alternate interior angles. Yep, they could have also said the vertical angles are congruent. But like I said, everybody thinks differently. So some people might say, oh, 2 and 3 are alternate interior angles. So if angle 2 is 40 degrees, then angle 3 is also 40 degrees because of the alternate interior angles theorem. And then for their angle 1, they might have, we know 3 is 40 degrees now. We fill that in. We know 2 is 40 degrees. So to find the last one, they might have done the consecutive interior angles, which have to be supplementary, and get 140 here. But they also might have used the linear pair idea. So either way, this person might have said angle 1 is 140 degrees, and their reason might have been because it's a linear pair with angle 2. And linear pairs are supplementary, or linear pairs add to 180, however you like to say it. All right, there's a couple different ways of doing that problem. You should be set to have a pretty fair experience with your assignment. You might find it easy. If you find it challenging, well, that's part of the process. We have a lot of ideas to synthesize, and getting this practice will help you to synthesize them. But you're going to have to put some mental energy into it. Good luck, and I'll see you in class very soon.